all see my screen?
Yeah, we can see it.
Okay, good. Thank you. So the last class, let's just write this question down. The question says, x1 minus 2s2 plus s3 equals to 0. Then we have 2s2 minus 8s3 equals to 8. Then we have negative 4x1 plus, this is what is missing there, 5x2 plus s3 equals to negative 9. Like I explained, for us to solve this problem, it's like I gave us 3 different methods for row operation. Is that you are doing replacement or interchange, or you are doing scaling. These are the things you can be doing when you are solving the problem. So today now, we'll be using this particular method of solving it. So let's look at it. Let's extract all our coefficients out, the solution. Let's take them out. The first row, the first equation, this is equation 1, equation 2, equation 3. The first equation, we have 1, negative 2. We are writing the augmented matrix, 1. Then everything equals to 0. The second equation is 0, 2, negative 8. This is 8. Then the third one is negative 4. This is 5. And this is 1. This is negative 9. I believe we can all see the board. So we have this. So the first thing we need to do is we are working towards to reduce. Remember, our target is to work on this, make this particular gentleman to be 1. So the upper triangle can be 0, the lower triangle also can be 0. So, but our target is, how do I make this one to be 1 and make the lower one to be 0 especially? So we can proceed by saying, let's look at the R. So for the first one, what do we do here? We can multiply. Since I know I need this to be 0, I can say 4R1 I say 4R1 plus R3. It will lead to my new R3. So 4R1. So R1 will remain itself. Look at it. 1, negative 2, 1, 0. R2 will remain itself. 0, 2, negative 8, 8. Then I need it for R1 now. So what it simply means is, let me just do the sketch here. 4 multiplied by 1, that is R1 we are working on, this one. 4 multiplied by 1 plus negative 4 plus negative 4. What do we have? You discover that we have 0. Then 4 again, multiply by next column, negative 2 plus 4 multiplied by negative 2 plus 5 equals to minus 3. So, we have 0 here, we have minus 3 here. So the next one will be 4 multiplied by 1 plus 1. What do we have? We have 5. So we have 5 here. Then 4 multiplied by 0, which is R1, plus negative 9. What do we have? Negative 9. So we have negative 9 here. Any question? So we can proceed. Now that we have this, the next thing we're going to do so who can tell us the next things to do, please? Who can tell us what to do next? So can we make this one to be 9x3? Let's make it 9x3, please. Make this one 9x3, the last one. So I have to recalculate this last row back. So what I did here is,
You call me?
so what we are going to do now is, let me calculate the last one back again, this particular one. So we have it to be 4 in brackets. R1 is 1 plus 9. R1 plus 9 will give us what? 4 plus 9 will give you 13. So put 13 there instead of 5. It's going to be 13. Okay. So, and the remaining one will be the same. Are we together? Okay.
Yeah.
What do you think would be the next step to take if you are the one calculating it? Out of the 3 steps. So if you look at row 2, something is common. I can do something in row 2. What do you think we can do in row 2? I can
Make the
reduce
2 a
row
1.
by what?
Divided by 2.
Divided by 2. Thank you. So we said 1 all over 2, row 2, will become a new row 2. Please take notes. So it's going to be 1, negative 2, 1, 0. So when we divide this by 2, we'll give 0, 1. This will be 1 over 2 multiplied by what? Negative 8. So you have negative 4. So we have negative 4. Then this is 4. The remaining one is 0, minus 3, 13, negative 9. Please take notes. So the next thing we need to do, remember, we need to make the lower to be 0. So how do we do that? What can we do to our row 3? Anybody?
Times it by 0.
Add 3.
R2, yes. R2 plus what? Look at it very well. So let's look at this. If I put this one there, if I said
Plus 3.
3R2, right? 3R2 plus R3. 3R2 plus R3 becomes our R3. Do you believe that? So remember, we are working on R3 now. So R1 is okay, R2 is okay, this is okay, then we have 0. R2 remain the same, 1, -4. Now, let's look at the R3. I said 3, R2. R2 here is 0 plus R3 also is 0. At that point, it's still 0. So we have 0 here. The next will be 3, R2 is 1 plus R3 is what? Plus R3 is what? -3. If you add the two together, we'll still give you 0. Then we have 3.
Yup.
Any question? R2 is -4 plus 13.
+1.
That's 1. So you have 1 here. Like I
So
told you,
that's it.
forget what happened to your augmented side. So let's just do the augmented now. We have 3. R2 is 4 plus R3 there is what? -9. So what do we have? This is 12 minus 9. That's 3. You have this. So now that we have this, you can see you already successfully reduced this. You have this one already. Then the entire here is also 0. It makes our work easy. Very simple now. So all you need to do is to rewrite your equation and get the unknown. How do we do that? That's not the final. So let's look at the final answer. The final answer will be, remember you have x1, s2, s3. So we'll take it like that. So 1 multiplied by x1 will be, remember, is x1. This is what I'm doing. Multiplied by this 1. So we have -2s2. Then plus, let me just do it this way. 1x1 -2s2 plus 1s3. Everything equals to 0. Then the second equation will be, we have 0x1 plus 1s2 minus 4s3 equals to 4. And the last one will be 0x1 plus 0s2 plus 1s3 equals to 3. So this is what we have. Then we need the value for x1, x2, and s3. How do we get it? It is simple. All we need to do is, let's start from the reduced one. Remember, this is, let's say this is equation 1, equation B, A, B, C. So let's start from equation C. From equation C, what do you have? You have it to be, from equation C, you have it to be 1s3 equals to 3, which is simply implies that s3 is equals to 3. Now we have s3. So we need to look for S, go to B, because in B, we don't have X1. Then we have X2. We can substitute our S3 there to get our S2. Are we together, please? Any question? Okay. Silence means no question, right? So we have 1S2 minus 4S3 equals to 4. So we substitute our S3 here. So meaning we have S2 minus 4 into 3 equals to 4. So in this case, we have S2 minus 12 equals to 4. S2 equals to 4 plus 12, where you take it to the other side. So our S2 is equals to 16. Now we know X2 and S3, so we need our X1. Which of the equation contain X1? You can see equation A is the one that contains X1. We put S2 and S3 there, then we have our A. We have our X1. So let's move on. So we have 1X1 minus 2S2 plus 1S3 equals to 0. We know plug X1, X2, and S3 there. So you have it to be X1 minus 2 into 16 plus S3 is what? 3 equals to 0. So our X1 will now be 16 multiplied by 3, which is 32 plus 3 equals to 0. This will be, our X1 will be negative 29 equals to 0. X1 is equals to 29. Therefore, X1, our solution is 29, S2, 16, and S3 equals to 3. Any question, please? Any question, please? Are we there?
Could you scroll back up so I was trying to write down some of the notes.
Okay, no problem.
Yeah.
I will also send the video. I think I will upload the link to you for you guys.
All right, thank you.
So, but you can still write the one you can write now. So by the time you are going through the video, it will also be part of what you do. Any question? Okay. So that is the by the way. So this place, the method here we use at this point, we call it this particular area of equation that we did, this particular from here, that what we call it back substitution. Method. So we use back substitution method. Anytime you get, once you reduce your matrix to this using Gaussian elimination method, once you get to this point, then you can proceed to back substitution method and try and substitute some of the value there. Okay, let's move to next topic and the next question. So for this, we want to check at this point, we want to check the existence and uniqueness. Existence and uniqueness of our system. So we want to determine if the system is consistent or inconsistent. So we want to know whether does a solution exist if the solution exists. Is it a unique solution? If it is a unique solution, does it have only one, just only one solution, or it has many solutions? So let's look at the example. Example, let's say number 2 says x squared s2 minus s2 minus 4s3 equals to 8. Let's say you have 0x1. Let me put it this way so that you understand what we are saying. Then you have 2x1 minus 3s2 plus 2s3 equals to 1. Then 4x1 minus 8s2 plus 12s3 equals to 1. So we have this system of equation. We want to check whether it's consistent or inconsistent. So let's look at it. The solution. We need to extract it. So we have 0, the first equation, 1, -4. Then we have here our argument aspect is 8. We have 2, -3, 2, 1. We have 4, -8, 12. We have 1. So now the first thing we need to do, remember the 3 rule. Is either you replaced, is either you swap, or you scale. So in this case, and I know that the first element entry must not be 0. So all I need to do is just to swap. I can swap 1 to 2 or 1 to 3, either of the two. But in this case, I choose to use R1 to swap to R2. So R1 to swap to R2 rather. So I will bring my equation R2 up now. It's going to be 2, -3, 2, then equals to 1. R1 will turn to R2. Then R3 remain R3. Okay. So the next thing I need to do is, which one do I need to reduce in this case? Now that I have R1, I have new R2. So which one do you think we can reduce? Anybody? So you agree with me if I say that if I multiply, remember R1 here, we need 1 as entry point. I can divide through by 2. 1 all over 2 R1. . to be my new R1 because I need 1 here. So it's going to be 1 all over 2 multiplied by 2 will give me 1, yes, minus 3 over 2, and the 1, and the last one will be 1 over 2. Don't be afraid of fraction. It will pay off at the end of the day. Here you have your 0 is here, 1, -4, 8. My 4 is here, -8, -12, 1. So the next thing is I need to eliminate, remember my target. Here must be 1, all true. And the lower triangle here should be 0. So, but now let's look at this. You agree with me if I said -4 R1 plus R3. It becomes my new R3. So, if it becomes my new R3, I have 1, -3 over 2, 1. So, my R2 remain R2. So, if my -2 become, so what do we have here is we have -4 R1 is 1 plus R3 plus 4. It turns to 0. So we have 0 here. Then -4 into R1 is -3 over 2 plus R3, -8. What do we have? What do we have for that? Anybody? So you agree with me, minus cancel minus. Here 1, here 2. 2 times 3, 6, minus 8 equals to -2. So this turns to -2. Then the last one will be -4 into 1 plus 12 is equals to 8. So we write 8 here. Then augmented side will be -1 all over 4, 1 all over 2 rather, plus 1. We have here 1, here -2. So we have it -1. So we have a new matrix. So what do we need to do at this point? Remember, we need to have 1 in the all other side. How do we achieve that? But not all the time, like I told you, it's the law of war. At times, some system might not obey it. That's why we have different consistent and inconsistent. So let's look at it. So in this case now, I need to eliminate these 2 to be 0. But now let's look at it. If I say 2R2 plus R3, 2R2 plus R3. So what do we have? Our 1 is still okay. 2R2 plus R3 will become your new R3. Don't forget. So this will be 0, will still be 1, and -4, 8. So how does it work? We can actually look at it in this way too. Our R2 is 0 here, plus R3 is 0, making 0. So we have 0 here. Then we have 2 again, multiplied by 1, plus -2. What do we have? 0. So we achieve this. But now let's look at the other side. We have 2 of -4 plus 8. We still have 0, so we have 0. Now, the last point will be 2 of 8 minus 1. We have 15. So we have 15 here. So it simply means we are at the point of no return. We just have to resolve this matter. So what do we do here is just to come. We need to go back to substitution now. Let's try this one. We have it to be 0x1 plus 0s2 plus 0s3 equals to 15. Mathematically, is it correct? No. At this point, we cannot continue because you can't say 0 equals to 15. That is inconsistent. Inconsistent. So we cannot proceed here. It simply means our system is inconsistent system. So we have to, that's how you prove the inconsistent and consistent. If it give you good results, good solution, if you have all these x1, s2, s3, we can say this system is consistent. But in this case, it is inconsistent because I can give you the metrics and ask you to show whether the system is consistent or not. Any question, please? Can we try this by ourselves? Because of our time, let's try this one. Just say 0x1 plus then have x1 plus no, let's make this one to be equals to 8. This equals to 10. So can we try this one? So how do we solve this? Anybody? For you to solve this, extract your matrix out of it, your augmented matrix, write it out. It's going to be 1, -2, 1, which is 0, 0, 2, -8, 8, 5, 0, -5, 10. So we are to solve this. If you solve it very well, your final answer will be 1, 0, 1, -1. If you solve it very well, that's what you're going to get. Any question, please? Do you want me to solve it?
Yeah.
Only one person? Okay. If you want me to solve it, please put it in a chat. Put it in a chat if you want me to solve it. Then Please put it in the chat so
Yes.
that we know the number of people that need it or not so that we can proceed. Oh, okay. I can see 4. Okay. Okay. Oh, wow. Okay, let's solve it then. Let's go back to the board. So now we all have idea of how to do this. So we have 1, -2, -1, 0. Now, what is the first things to do? Always remember your targets, that you need this to be 1 and this place also to be 0, probably. It will help you to be able to navigate the system. However, let's try this one and see how far we can go. So the first thing I would do here is I can say that -5 multiplied by R1 plus R3. It will lead to my new R3. Don't forget. So if that would lead to my new R3, meaning that R1 will still remain R1, R2 will still remain R2. Zero, 8. So what I did is -5 multiplied by 1 plus R3 is 5 equals to 0. So this plus this will give you 0. Then the next one will be -5 multiplied by -2 plus 0 will give me 10. Put the 10 here. The -5 of 1 plus -5 will give me what? -10. Be careful here. -10. Then -5 of 0 plus, I mean, augmented side plus 10. We still maintain 10. We still maintain my 10. Any question? So, one step at a time. I can proceed now. Something is common in my R2. I can do that fast. Who can tell us what to do in R2? Please look at the board. Your R2, what do you do?
Times by half.
By half, thank you. R2 by half will lead to new R2. So others still remain. So you have 0. By half will give you 1. By half will give me -4. By half will give me 4. So I have 0, 10, -10, 10. So the next thing is, which of the row do you think I can still perform something? Do you see R3? What can we do to R3? Anybody? Do you agree with me? Multiply 1/10 by your R3, you have it to be 1, -2, 1, 0. 0, 1, negative 4, 4, 0, 1, negative 1, 1. Do you agree with me? So my R2 and R1, my R2 and R3, something good can still come up of them. Remember, this side must be 0. So I can go ahead by saying that R2 minus R3 will lead to R3, because that's my target. It will be 1, negative 2, 1, 0, 0, 1, minus 4, 4. So this is 0, 1 minus 1 is 0. So you have minus 4 minus 1. So what do we have? Negative 3, right? I have negative 3. Then we still need R2 minus R3. That is 4 minus 1, 3 also. So this is what we have. But that's not the final, because we know that we can still work on this R3. 1 all over 3 R3 turns to new R3, because the last point must be 1 too. So it's 0, 1, negative 4, 4, 0, 0, negative 1, and 1. Any question, please? I can reduce further if I don't want to pass through back substitution. I can reduce further. How do I do that? You agree with me if I say that 2R1, R2, because I need to eliminate this guy too. I can do that. 2R2 plus R1. It will lead to my new R1. So 2R2 plus R1. New R1, let's do that. So it's going to be 2 in brackets 1, 2R2, sorry, 2 multiplied by 0 plus 1 equals to what? 1. So we still maintain our 1 in R1. Then 2 in brackets 1 plus negative R2, negative 2 rather. You have 0. This turns to 0. 2 in bracket 1. No, sorry, 2 in bracket 4. 2 in bracket negative 4 rather. Negative 4 plus 1. What do you have? Minus 7. So you have minus 7 here. You have 2 in bracket 4 plus 0 is equals to 8. So we have 8 here. So then the next thing is to write whatever we have here. 0, 1, negative 4, 4. Then 0, 1, negative 4, 4. Then we have 0, 0, negative 1, 1. So is that all we need to do? But don't forget, we don't need the negative here because it must be 1. So I can go ahead, multiply the R3. I'll just do it this way. R3 all you need to do is -1 to new R3. So what do we have here? We have 1, 0, -7, 8, 0, 1, -4, 4, 0, 0, 1, -1. So that's our new matrix. So is that a final? We need this -4 and -7 to be 0. That would be our target now. How do we make it to be 0? It's pretty simple. All you need to do is 4R3 plus R2. It leads to your new R2. Then we can also do this at the same time. 7R3 plus R1 leads to my R1. So you have to be careful when you are solving this. We can solve the one of R1 first. If you want to solve the one of R1, it simply means R3 is, you have 7R3. R3 is 0 here, plus 0. No, sorry, plus 1. We give me what? 1. So we have this. Then we have 7 of 0 again, plus 0, 0. Then 7 plus multiplied by 1 plus -7. What do we have? 0. So you can see we're able to eliminate this. Then we know 7 of -1 plus 8 will give me what? 1. That's augmented 1. Then the R2 remain, we need to work on R2 too. 4 multiplied by R3. 4 multiplied by R3 will be 4 into R3. R3 is 0 plus R2, 0. Will give me what? 0. Then the same 4 multiplied by 0 plus 1 will give me 1. Then 4 multiplied by 1 plus -4 will give me 0. So at the end of the day, you have 4 multiplied by -1 plus 4 will give me 0. So this is 0. Then the R3 will remain 0, 0, 1, -1. So you can see what we get at the end of the day. Don't forget, this is your X1. This is your X1, S2, S3. So if you want to write this equation out now, you only have, for first column, you only have X1, 1 of X1, the rest are what? 0 plus 0 equals to 1. The second equation will be 0 plus 1s2 plus 0 equals to 0. Then S3 will be 0 S3. Right. This will be 0, 0. This is 3, S3, rather. This will be S3 equals to -1. Therefore, S1 equals to 1, S2 equals to 0, then S3 equals to -1. So we have solution for this. So these are the ways to solve the system of equation. Any question? Because of our time,